Welcome. Today we are looking at Introduction to Stoichiometry. This is a key topic in your chemistry exams for SS1. Pay close attention. Let us begin. First, let me explain what stoichiometry is. Stoichiometry is the branch of chemistry that deals with the quantitative relationships between reactants and products in chemical reactions. It is the calculation of the amounts of substances involved in a chemical reaction. The word stoichiometry comes from Greek words. Stoichion means element, metron means measure, so stoichiometry means measuring elements. Stoichiometry is essential for understanding chemical reactions. It allows chemists to predict how much product will be formed. It allows them to determine how much reactant is needed. It is used in industry, research, and everyday life. For example, a chemist needs to know how much of each reactant to add to make a specific amount of product. Stoichiometry provides the answers. Now let me explain the mole concept. The mole is the SI unit for amount of substance. 1 mole contains the same number of particles as there are atoms in 12 grams of carbon, 1, 2. This number is called Avogadro's number. Avogadro's number is 6.02 times 10 to the power of 23. 1 mole of any substance contains 6.02 times 10 to the power of 23 particles. These particles can be atoms, molecules, ions, or electrons. The mole is a counting unit. It is similar to a dozen. A dozen means 12. A mole means 6.02 times 10 to the power of 23. The mole is used because atoms and molecules are very small. It is easier to work with moles than with individual particles. For example, 18 grams of water contains 1 mole of water molecules. This is 6.02 times 10 to the power of 23 molecules. The mass of 1 mole of a substance is called the molar mass. The molar mass is the mass in grams of 1 mole of a substance. It is numerically equal to the relative atomic mass, or relative molecular mass. For example, the molar mass of carbon is 12 grams per mole. The molar mass of water is 18 grams per mole. The molar mass of sodium chloride is 58.5 grams per mole. Now let me explain how to calculate the number of moles. The number of moles can be calculated using the formula. Number of moles equals mass divided by molar mass. For example, if you have 36 grams of water, the number of moles is 36 divided by 18. This gives 2 moles. If you have 24 grams of carbon, the number of moles is 24 divided by 12. This gives 2 moles. If you have 117 grams of sodium chloride, the number of moles is 117 divided by 58.5. This gives 2 moles. You can also calculate the number of particles using Avogadro's number. The number of particles equals number of moles times Avogadro's number. For example, 2 moles of water contains 2 times 6.02 times 10 to the power of 23 molecules. This is 1.204 times 10 to the power of 24 molecules. The number of particles can also be atoms, ions, or electrons. For example, 2 moles of sodium chloride contains 2 times 6.02 times 10 to the power of 23 formula units. This is 1.204 times 10 to the power of 24 formula units. Now let me explain Avogadro's law. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain the same number of molecules. This means that 1 mole of any gas occupies the same volume at the same temperature and pressure. At standard temperature and pressure, 1 mole of any gas occupies 22.4 liters. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere. This volume is called the molar volume. For example, 1 mole of oxygen gas occupies 22.4 liters at standard temperature and pressure. 1 mole of carbon dioxide also occupies 22.4 liters. Avogadro's law is important for gas stoichiometry. It allows chemists to convert between volume and moles for gases. Now let me explain relative atomic mass. Relative atomic mass is the average mass of an atom of an element compared to 1/12 of the mass of a carbon, 1,2 atom. It is a weighted average. It takes into account the abundance of each isotope. The relative atomic mass is the number you see on the periodic table. It is not a whole number because it is an average. For example, chlorine has a relative atomic mass of 35.5. This is because it has two isotopes. Chlorine 3,5 has an abundance of 75%. Chlorine 3,7 has an abundance of 25%. The average is 35.5. Relative atomic mass is used to calculate molar mass. The molar mass of an element is the relative atomic mass in grams. For example, the molar mass of sodium is 23 grams per mole. The molar mass of oxygen is 16 grams per mole. Now let me explain relative molecular mass. Relative molecular mass is the sum of the relative atomic masses of all atoms in a molecule. It is the mass of a molecule compared to 1/12 of the mass of a carbon, 1,2 atom. To calculate relative molecular mass, add the relative atomic masses of all atoms in the formula. For example, water has the formula H2O. The relative atomic mass of hydrogen is 1. The relative atomic mass of oxygen is 16. The relative molecular mass of water is 2 times 1 plus 16. This gives 18. Carbon dioxide has the formula CO2. The relative atomic mass of carbon is 12. The relative atomic mass of oxygen is 16. The relative molecular mass of carbon dioxide is 12 plus 2 times 16. This gives 44. Sodium chloride has the formula NaCl. The relative atomic mass of sodium is 23. The relative atomic mass of chlorine is 35.5. The relative formula mass of sodium chloride is 23 plus 35.5. This gives 58.5. Relative molecular mass is used to calculate molar mass. The molar mass of a compound is the relative molecular mass in grams. Now let me explain how to calculate the percentage composition of a compound. Percentage composition is the percentage by mass of each element in a compound. To calculate percentage composition, use the formula. Percentage equals mass of element in 1 mole divided by molar mass of compound times 100. For example, water has the formula H2O. The molar mass of water is 18 grams per mole. The mass of hydrogen in 1 mole is 2 grams. The mass of oxygen in 1 mole is 16 grams. The percentage of hydrogen is 2 divided by 18 times 100. This gives 11.1%. The percentage of oxygen is 16 divided by 18 times 100. This gives 88.9%. Carbon dioxide has the formula CO2. The molar mass is 44 grams per mole. The mass of carbon is 12 grams. The mass of oxygen is 32 grams. The percentage of carbon is 12 divided by 44 times 100. This gives 27.3%. The percentage of oxygen is 32 divided by 44 times 100. This gives 72.7%. Percentage composition is used to determine the formula of a compound. Now let me explain how to calculate empirical and molecular formulae. The empirical formula is the simplest whole number ratio of atoms in a compound. The molecular formula is the actual number of atoms in a molecule. The molecular formula is a multiple of the empirical formula. For example, hydrogen peroxide has the empirical formula HO. The ratio of hydrogen to oxygen is 1:1. The molecular formula is H2O2. The actual number of atoms is 2 hydrogen and 2 oxygen. Glucose has the empirical formula CH2O. The ratio is 1 carbon, 2 hydrogen, 1 oxygen. The molecular formula is C6H12O6. The actual number of atoms is 6 carbon, 12 hydrogen, 6 oxygen. To calculate the empirical formula, find the moles of each element. Divide by the smallest number of moles. This gives the ratio. To calculate the molecular formula, divide the molar mass by the empirical formula mass. This gives the multiplier. Multiply the empirical formula by the multiplier. Now let me explain how to balance chemical equations. A chemical equation shows the reactants and products of a reaction. The equation must be balanced. The number of atoms of each element must be the same on both sides. This is the law of conservation of mass. Atoms are not created or destroyed in a chemical reaction. They are rearranged. To balance an equation, use coefficients. Coefficients are the numbers in front of the formulas. Do not change the subscripts. For example, the reaction between hydrogen and oxygen to form water is written as 2H2 plus O2 equals 2H2O. The coefficients are 2, 1, and 2. The left side has 4 hydrogen atoms and 2 oxygen atoms. The right side has 4 hydrogen atoms and 2 oxygen atoms. The equation is balanced. The reaction between sodium and chlorine to form sodium chloride is written as 2Na plus Cl2 equals 2NaCl. The coefficients are 2, 1, and 2. The left side has 2 sodium atoms and 2 chlorine atoms. The right side has 2 sodium atoms and 2 chlorine atoms. The equation is balanced. Now let me explain how to use stoichiometry in calculations. Stoichiometry calculations use the mole ratios from the balanced equation. The coefficients in the balanced equation give the mole ratios. For example, the equation 2H2 plus O2 equals 2H2O shows that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. If you have 4 moles of hydrogen, you need 2 moles of oxygen. You will produce 4 moles of water. You can also calculate mass relationships. First, convert mass to moles. Then use the mole ratio. Then convert moles back to mass. For example, if you have 36 grams of water, how many grams of hydrogen and oxygen are needed? First, convert 36 grams of water to moles. 36 divided by 18 equals 2 moles. The equation shows that 2 moles of water are produced from 2 moles of hydrogen and 1 mole of oxygen. So you need 2 moles of hydrogen and 1 mole of oxygen. Convert to grams. 2 moles of hydrogen is 4 grams. 1 mole of oxygen is 32 grams. The total mass is 36 grams. This matches the mass of water. The law of conservation of mass is obeyed. A common exam question asks you to define the mole and explain its importance. Here is a sample answer. The mole is the SI unit for amount of substance. 1 mole contains 6.02 times 10 to the power of 23 particles. This number is Avogadro's number. The mole is important because it allows chemists to count particles by weighing them. It is used in stoichiometry to calculate amounts of reactants and products. The mole makes chemical calculations possible. Another exam question asks you to calculate molar mass. Here is your answer. Molar mass is the mass of 1 mole of a substance. It is numerically equal to the relative atomic mass or relative molecular mass. To calculate molar mass, add the relative atomic masses of all atoms in the formula. For example, the molar mass of water is 18 grams per mole. The molar mass of carbon dioxide is 44 grams per mole. The molar mass of sodium chloride is 58.5 grams per mole. Another exam question asks you to balance a chemical equation. Here is your answer. To balance an equation, count the atoms of each element on both sides. Add coefficients to balance the atoms. Do not change the subscripts. Check that the number of atoms of each element is the same on both sides. For example, 2H2 plus O2 equals 2H2O is balanced. The left side has 4 hydrogen and 2 oxygen. The right side has 4 hydrogen and 2 oxygen. Let me give you a quick summary. Stoichiometry is the calculation of amounts in chemical reactions. The mole is the SI unit for amount of substance. 1 mole contains 6.02 times 10 to the power of 23 particles. Molar mass is the mass of 1 mole. Relative atomic mass is the average mass of an atom. Relative molecular mass is the sum of relative atomic masses. Percentage composition is the percentage of each element in a compound. Empirical formula is the simplest ratio. Molecular formula is the actual number of atoms. Chemical equations must be balanced. Stoichiometry calculations use mole ratios. Practice these concepts. When you have them down, move to topic 10.